Given f of x equals that polynomial, determine the remainder when f of x is divided by each of the following binomials. But we're not allowed to divide. We just have to know the remainder. All right, I'm going to start off with, so this x minus 2. All right, so let's let x equal 2, because that's the thing that makes this 0. And so f of 2 is equal to 2 to the 4 plus 5 times 2 cubed plus 3 times 2 squared minus 7 times 2 plus 10. That equals 2, 4, 8, 16. Plus, let's see, this is 8, 40, so 56. Plus another 12, so 68. Minus 14, so 54, so 64. Okay, that means the determine the remainder. The remainder will be 64. That's for A1. 2. F of negative 4. So negative 4 to the 4 plus 5 times negative 4 cubed plus 3 times negative 4 squared minus 7 times negative 4 plus 10. Negative 4 to the 4, so it's 256. Negative 4 to the 3, 64 times, so plus, oh, that's negative 64, my bad. So it's going to be minus 320. This is going to be 16, so 48. And plus 28 plus 10. So we got 256 minus 320 plus 48. So that's going to be this, and this is going to give me 304, 332, 342. So it's going to be 22. That's the remainder. And number 3, just let x be 1. Well, that'll be easy. All right, so 1 to the 4 is 1, plus 5, that's 6, plus 3, that's 9, minus 7 is 2, plus 10, 12. So f of 1 equals 12. There's your answer. All right, part B. Are any of the binomials in part 1 factors? Well, no. If they're factors, B. No. If they were factors, then there would not be a remainder. Right? Like 37 divided by 7 equals 5 with a remainder of 2. So that means that 7 is not a factor of 37. But 35 divided by 7 has a remainder of 0 because it divides perfectly. So no, they're not. They all have remainders. Which of the following functions are divisible by x minus 1? All right, let's plug in a 1, and if we get a 0, then that means, right, the idea is if x minus 1 is one of the factors in factored form, then we know if we plug in an x equals 1, that the whole thing will equal 0. Right? Well, whether it's in factored form or standard form, it's the same thing. So let's just check to see if that's the case, and if it is the case, then we know that that must be one of the factors. Right, so here we're plugging a 1. You got 1 minus 15 times 1 times 1 times 1. So negative 14 plus 2, negative 12 plus 12 is 0 plus 10, or minus 10 is negative 10. So no, not divisible. Right, you got 5 minus 4 is 1. But yep, this one gives you 0. Yes, because g of 1 equals 0. F of 1 did not equal 0. It equaled 10. All right, so let's see. 1 minus negative 6 plus 11. Nope. H of 1 does not equal 0, so that's a big no. And yes, j of 1 does equal 0. So there we go. Determine all the factors of the function of this function. All right, well, let's find out what value of x gives us 0 first of all. Let's try 1. This will be good. 1, 2, 3. Nope, that's not going to do. I'm going to try all the factors of -6 that are obvious. So like maybe -2, -3, +2, +3, 1, -1, stuff like that. All right, let me try 2. 2, 4, 8 plus 2, 4, 8. That's 16 minus 10. Yep, that works. So f of 2 equals 0. Here, let me get rid of all this stuff first. All right, so number 3. We know that f of 2 equals 0. Therefore, x minus 2 is a factor. Let's divide it. Let's see what's left after you. So let's go x minus 2. This is going to be x cubed plus 2x squared minus 5x minus 6. So you got x squared. Let's get 4x squared. So you got plus 4x. Let's see. X negative, so you got 3x. So you get plus 3. I guarantee there's going to be a remainder of 0 because we already figured that out right here. So this is going to be minus, so 3x minus 6 and -6. So there you go, 0 remainder. It's perfect. And this times this equals this. So the quotient. So now we have x minus 2. Here, let's go back. We can say that f of x equals x minus 2 times x squared plus 4x plus 3. I don't really need to test any other things. I could factor this guy pretty easily. 3 and 1 looks like it'll work, right? 3 plus 1 is 4, and 3 times 1 is 3. So x plus 3, x plus 1 are the other two factors. All right, so if I were to graph this just for fun, I know that at x is 2, x is -3, and x is -4. Those are the three zeros. I know it's a leading coefficient that's positive 1. So this is what my graph would look like. Boom, boom, boom. All right, and I actually have the standard form right here, so I know that if x is 0, y is -6, so I even know that. Beauty. All right, let's go to the next question. State the remainder when x plus 2 is divided into each polynomial. All right, well, all we have to do is, to find the remainder, just let x be -2, because that's what makes this 0, and that'll give us the remainder. So x, so -2 squared plus 7 times -2 plus 9 equals, let's say this is 4, so -10 plus 9, so -1. The remainder is -1. That's for part A. Part B, -2 times -2 times, so -8, -48. 4 times 20 is 80, so 76. Minus 22 minus 11, and that's going to be 70, 81, so -5. C, -2 to the power of 4, 16, minus 5 times -20, plus 4. Oh, that's going to be 0. This one's actually a factor, no remainder. So one of the factors of this guy is x plus 2. Part D. You know what? For fun, I'm going to see what the other factors are. I'm interested now for some reason. Plus 4. Let's divide it by x plus 2. So it's going to be, oh, you know what we need to do here? I'm missing some terms. You don't want to be doing division while you're missing terms. It's plus 0x to the 3 minus 5x squared plus 0x plus 4. Alright, so you're going to get an x cubed up here. You're going to get x to the 4 plus 2x cubed. Negative x 2x cubed, so you got minus 2x squared. Negative 2x cubed minus 4x squared. Negative 5 minus negative 1, negative 4 is negative x squared. So you got minus x squared minus 2x. 0 minus negative 2 is 2x. So it's plus 2. And you're going to get 2x plus 4. And you see how this has a 0 remainder. And we knew that because it had 0 remainder. And so this would be x cubed minus 2x squared minus x plus 2 times x plus 2 gives us this guy. And then, of course, we could try to factor that down even farther if we wanted to. I'm going to clear the screen to do part D. Oops. Try that one more time. Alright, part D. Just have to plug in a negative 2. So here we're going to get 16. Negative 8, so plus another 16. This is going to be 4, so minus 44. Minus 20. And minus 2. So we got, this is minus 64, minus 66, so minus 50, and minus 34. Let's go E. You got negative 8. This is going to give me 4, so plus 12, plus 20, plus 6. So we got 8 and 4, 24, 30. By the way, it's likely that I make mistakes on these guys, so just let me know, email me or something if you see a major mistake. 16 times 4, 64. Negative 8, so it's what, minus 96. 4, so like a deck of cards, you got 52, well, negative 52, plus 66, and plus 18. What do we got here? So this is going to be minus 148. And then you're going to get plus 120, 130, 148. Oh, equals 0. This one, so x plus 2 is a factor in f. All right, let's go to the next question. All right, this looks like it's going to be tedious. We got a lot of factoring to do. All right, let's start with A. I'm going to test numbers that are going to make this 0. So I'm going to use factors of 60, but I'd like to start with 1 just to see. Oh, that's not going to do. 1 and 9 and 8, there's no way that's going to give me 60. All right, let me try a number like 6. Let's try 6. So 6 cubed, what's that, 216? Plus, this is going to be 1.5 of that, so 324. And plus, oh yeah, this is way too high. I think we're going to have to use a negative here. Let's go negative 6. So we're going to get negative 216 and positive 324 and minus 48 and minus 60. Is that going to do it? 108. Oh yeah, that'll do it. So negative 6 was a good guess. So I know that x plus 6 is one of the factors. And I'm going to do the Portal method to factor this. I know this is going to be an x squared, because that's the only way to make the first one x cubed. Which means in one of these terms I'm going to get a 6x squared, and I'm going to need 3 more. So that, this and this will give me 3 more. Which means I'm going to get an 18x, and I'm going to need minus 10 more. And that'll give me negative 60. All right, fully factor. All right, so two numbers, I would say positive 5 and negative 2, multiply to give negative 10 and add to give 3. So this is equal to x plus 6, x plus 5, x minus 2. Done. Part B. That wasn't so bad. All right, part B. Let's just try a number. So let's try 1. 1 minus 7 minus 6. Nope, but negative 1. Let's try. Negative 1 is going to give me negative 1 plus 7, which is 6 minus, so negative 1 works. So we know that f of negative 1 equals 0. So let's go. F of x equals x plus 1 is going to be a factor, because I know when I plug in a negative 1, I have to get 0, as evidenced by what I just did. So that means that has to be one of the factors. And, okay, so let's go. X squared, that'll give me my x cubed. But now I have a 1x squared, and I want 0x squared. So I have to go minus x squared. That gives me a negative 1x. I need 6 less. And that'll give me my negative 6. There we go. All right. Let's see. Multiplies to give negative 6, adds to give negative 1. How about negative 3 and positive 2? Yep. So this f of x equals x plus 1, x minus 3, x plus 2. Done. C. Let's try a 1. That's always a good one. So 1 minus 5 is negative 4 plus 4. Yeah, 1 works. F of 1 equals 0. So x minus 1 is a factor of f of x. F of x equals x minus 1 times x to the power of 3. That gives me x. So minus x to the 3 plus x squared minus x squared. So minus another 4 x squared. It's going to be 4 plus 4x. I have to do minus 4x and gives me a plus 4. Perfect. Oh, we have to find another thing. Okay. So if I plug in a 1 here, that's 1, 2, minus 4, that's not going to work. But oh, negative 1 I bet works. So this is going to give me negative 1. This will give me a positive 1, because negative 1 squared is positive 1. This will give me a positive 4. This will give me a minus 4. So negative 1 works. That means in this it'll equal 0. So that means in the whole thing it equals 0 as well if x is positive 1. Right? So, I mean if x is negative 1. So we can put that up here. F of negative 1 equals 0, 2. So we know that x minus 1 is a factor and x plus 1 is a factor. And the remainder is going to be x squared. That's going to give me an x cubed plus x squared. So I don't need any, I don't even need, like, so it's plus 0x I can put. I'm not going to put that though. Minus, plus accidentally, minus 4. And that'll give me, so let's just double check. You got your x cubed plus x squared. You got your minus 4x and minus 4. Yep, that works. And then x squared minus 4. That should be easy. It's just, so this is just x minus 1, x plus 1, x minus 2, x plus 2. This is just a difference of squares. There you have it. So when I started, I could have used 1, negative 1, 2, or negative 2. Those are the 4 things that would make my original here equal 0. And we knew we were going to get 4 factors, right? Because, well, we have a feeling because it's x to the power of 4. Sometimes you might not get, like sometimes it's not factorable. Like if we ended up with an x squared plus 4, you can't factor that. Well, we can talk more about that in class. Let's get rid of this junk. And go to part D. I'm just going to try 1. 1 plus 3 is 4. Oh, that's not going to work. Let's try negative 1, see if that helps. This is still going to be 1, but now it's going to be minus 3. So we're at 1 minus 3 is negative 2. This is going to be a minus 38, so we're at negative 40. This is going to be minus 24, so minus 60. Yep, that works. Negative 1 worked. So f of negative 1 equals 0. And that means that f of x equals x plus 1. That way we know that when x is minus 1, that this will equal 0. Times, let's see, we got x cubed. That's going to be 1x. That's going to give me an x to the 4, but it also gives me a 1x cubed from these two. And we need 3x cubed, so I need 2x squared to give me the other 2. Now that's going to give me a 2x squared, and we need negative 38x squared, so I need minus 40x. That's going to give me a minus 40x, and I'm going to need another 64 x's, and that's going to give me my 64. Perfect. I still need another number. 1 didn't work before, so it's still not going to work now. Negative. Let's see if negative 1 works again. Maybe it will work again. So we got your negative 1 here. Negative 1 squared is 1. So plus 2. This is going to give me plus 40. No, that's not going to work. Oh, well, good thought, Porto. Let's try negative 2. This is going to give me a negative 8. Negative 2 is going to be plus 8. Oh, that does not look good. Remember, we want numbers. The last numbers in each one of these factors have to multiply by 6 to give 64. Let's try 4. Let's try negative 4. Negative 4 cubed is actually negative 64. That's going to cancel this positive 64. That's good. And negative 4 squared is 16. No, that's not going to do. What if I... Alright, what else could be used to multiply to give 64? Let's try 8. Let's try negative 8. So f of negative 8 equals... I should be calling it f of, yeah. Let's go negative 8 plus 1 times negative 8 cubed. So negative 8 times negative 8 is 64 times negative 8. 64 times 10 is 640 minus 128. So 512. So negative 512 plus negative 8, 64 plus 128. Plus 320. Oh, this is looking promising. Yep, this does equal 0. So this is going to be negative 7 times 0, which is 0. That's beautiful. All right, so that means that f of x has a factor of x plus 1, and x plus 8 was another one. And this one will be easy now. We're down to a quadratic, so this gives me x cubed plus 8x squared minus 6x squared minus 48x plus 8x plus 64. There we go. So f of x equals x plus 1 x plus 8. And what do we got? Negative 4, negative 2. X minus 4, x minus 2. Darn, I should have tried positive 2 and positive 4. That would have been easier than negative 8. Anyways, we have this guy factored. Alright, let's erase this garbage and do part E. So E. Oh, nice small numbers. Let's try f of 1 equals 1 minus 1 plus 1 minus 1. Yep, that worked. So f of x, that equals 0. So f of x equals x minus 1, x squared. That gives me minus x squared, which is perfect. So plus 0x. That gives me, I need plus 1 more. There we go. X squared plus 1. This does not factor. It certainly does not factor. X squared plus 1, I'll tell you a few reasons. I know x squared plus 1 is a parabola. It's your normal parent parabola, but pushed up 1. So it has no spot where it equals 0. Right? And if it factored into x minus something, well then a and b would be the places where it equals 0. Well, there are no a and b where it equals 0. So just this thing just does not factor. And like the other way of looking at it is, what x value can I put in here to make this 0? Well, that means that x squared would have to equal negative 1. Well, it's impossible. There's no x value that's going to equal a negative 1. So this is fully factored. That's the best we can do. Let's go to f. F says, okay, I'm going to try let's try f of 1. You got 1 minus 1 is 0, plus 2 minus 2, that's 0, plus 1, yeah, that worked already. That was a beautiful one. Beautiful try. F of 1 equals 0. So we know that f of x equals x minus 1 times x to the 4 minus, so that's x to the 5 minus 1x to the 4. So we get no x to the 3's. So we need plus 2x squared. That's 2x to the 3. It'll give me minus 2x squared. That's enough. And we need an x. So we do a plus 1, and that'll get you the rest of it. Okay. All right, so I do confess I checked the x minus 1 first, because I know all of the end numbers have to multiply to give you a negative 1. But now I'm looking here, and I'm thinking, what kind of a number can I put in here to make this equal to 0? Well, we know this is equal to 1, so that means these two together have to be negative 1. But how are you going to get a negative out of an x to the 4 and an x squared? Right? No matter what number I put in for x to the 4, the answer is not going to be a negative number because it's to the power of 4. The x squared will never be a negative number. So you're never going to get negative 1 so that we can make this whole thing 0. So this is it. We can't factor this any farther. There's nothing else that's going to equal 0. So we're done. F of x equals x minus 1, x to the power 4 plus 2x squared plus 1. Let me show you the graph of this on Desmos. So I just want you to observe that this is the graph. You can kind of see how there's some funky stuff going on here. So you know it's not just like a straight line. This is a 5th degree polynomial, and from what we know about polynomials, this almost seems like maybe it's a 3rd degree, like it kind of goes up, sort of threatens to go down, but it doesn't, and then it goes back up again. But if you took the first, like if you started taking dots every, like you just looked at the height every one at a time, or every two, or like that, like in regular intervals, if you took the height in regular intervals, and then you took their first differences and second differences and third differences, those would not be all the same. but the fourth differences wouldn't, but then the fifth differences would be. So that's the way you can really know for sure that this is a fifth degree polynomial. But by the equation, we know just because it's to the power of 5. But I just wanted you guys to see that there's only one way to make this guy equal 0, and that's when x equals 1. All right? The other factor here, this can't factor because there's no other way to make it equal 0. And as you can see from the graph, that's the only place that the graph actually goes through the x-axis, is right at x equals 1. All right, last question. When ax blah 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 blah, that's some polynomial, is divided by x minus 1, the remainder is 10. When it is divided by x minus 2, the remainder is 51. Find a and b. All right, so if the remainder is 10, then that means that f of 1 has to equal 10, right? Because when x equals 1, the remainder will have to be 10. We also know that f of 2 has to equal 51. All right, so let's try it. Oh, not x. We know what x is. Let's say for a times 1, we're letting x be 1. By the way, I guess I was calling this f of x. I should have mentioned that. So let f of x equal that, and that way I can name it f of 1 and f of 2. All right, so a times, so let's say f of 1, which is a times 1 cubed minus 1 squared plus 2 times 1 plus b. That should equal 10. Let's clean that up a bit. This is just a minus 1. Let's clean that up better. So minus 1 plus 2. So plus b plus 1 and plus b is equal to 10. And let's just say a plus b must equal 9. All right, but we also know f of 2. So f of 2 equals 51. So that means a times 2 cubed minus 2 squared plus 2 times 2 plus b has to equal 51. Clean that up. You got 8a minus 4 plus 4. So just 8a plus b equals 51. All right, let's isolate. Let's isolate b. That'll be easy. So here b equals 9 minus a. And then we could say that this guy is just 8a plus b, which is 9 minus a, equals 51. So we can say 8a, so 7a equals 51 minus 9, so 42. And that means that a equals 6. Let's find out what b is then, knowing that a plus b equals 9. So 6 plus b equals 9, and b must equal 3. Find a and b. Oh, looks like we found a and b. Double check if a and b, so 8 times a, so that means 8 times 6, 48, plus 3 is 51. Yep, and 6 plus 3 is 9. So this is good.